Welcome back, everybody. So today is part two. It's not the same electrical panel, so I made a short asking for some help on knowing a little bit more information on these power supplies. You guys came in real clutch, giving me some pretty concrete answers, explaining to me why I should stick with the 36 volt instead of going with a 24 volt setup. So ended up deciding to go with a bigger panel since these two power supplies will probably go in it. I'm not going to buy another 24 volt that's smaller than this. I'm just going to use this one since I already have it. So these two will fit inside this big electrical panel. Also got myself some more terminal blocks. Got myself finally my connectors with my shielded cable from my sensors, which I'll be installing with my step bit. I printed up some stops for the bearings. I still have stuff that's coming in. I printed up these stands for the circuit board. And I got most of my stuff. So the other day, the day after I filmed the other video, I ended up getting my aluminum extrusion. It's way smaller than what I thought, what I imagined. That's what happens when you buy millimeter stuff and you're so used to the inch system. I got two sets of rails. So these two boxes are rails. This box is the aluminum extrusion. There's 5 pieces of 1,500 millimeters. This is 1,500 millimeters, so it's about I think 59 inches. So I'm just gonna get straight to it and work on this panel. I took out the plate that goes all the way in the back, and I'm just gonna work on this instead of work on the big panel. So I'll just see if I start with that, or if I start by drilling out my holes and installing my connectors first. But I mean, nothing. I'm in no rush to do the whole setup. I mean, whatever comes first, right? So I'll put the camera down, put my time lapse, and start installing the stuff that I took out of the other box. I did not film the dismantling of the other box. It basically just, I took off the DIN rails and took out the connectors and went with this bigger box here, which ended up costing me nothing since it was dented. So Amazon reimbursed me 100% of the box, so that wasn't too much of a hard pill to swallow. So let's get to it. So before I do put in time lapse, though, I just wanted to mention to everybody who did comment in my short and that suggested me to stay with that 36 volt power supply, and that went ahead and explained to me a bit how the controllers work, because when I was reading the motor spec sheets, I was under the impression that they would step down the voltage. I just want to say thanks a lot for the info. I mean, it's information that's going to help me move forward with this project. Probably if I would have went a lot further with the project, probably would have ran into some issues, or just had an underperforming machine in general. But you don't see that often now these days with people helping each other out. I mean, a lot of people are just like in their own little corner, keeping all the information. And I mean, I just really appreciate all the help that you guys gave me. So I just want to mention that. Thanks a lot for the people who did comment. Guys, I just want to go a little bit over what the people online told me as to like what caused me to change my idea. Basically, people told me that some people had some non-constructive comments, like you know, more voltage is better, and not explaining why, and me not understanding the system. If you tell me something like that won't, it doesn't help me at all. But some other people were explaining to me how the drivers don't actually step down, but just transfer the voltage over, but keep the same amps, so keep the amperage constant, which I still don't know if that's 100% true, but I'm going based off what other people told me, since I don't really know any of this. And so basically I told myself, well, I don't really understand the schematic, like the spec sheets of motors, so I mean, I guess somebody else's guess is probably better than mine. So that's what got me to keeping the 36 volt system and not changing out for the 24 volt. And so that's basically what I found. The guy explained to me how, told me that if I were to go to like at 24 volts, I'd lose about a third of my speed, since 24 volts is about a third less, or 2/3 of 36, which makes sense. But I mean, like, thank God that people mention stuff like that, or else I'd probably be just going into a blind hole here, and just do whatever, and probably I've been really sad of the end result if I didn't read the comments or ask for help. And that's that's why I went with a bigger box, because the old box, if you saw the video, this power supply here fit not very well in the other box, and it still doesn't fit very well on this panel, but there's extra space on the sides of these panels, and I'll be able to mount this box on the wall of the enclosure, and the other one I'll be able to mount it on the bottom of the enclosure. So basically on the enclosure I'll have two power supplies that are mounted directly to the enclosure via screws, like metric screws. And basically that's going to save me a lot of surface area on this panel. And basically I got some cable trays that are coming in that I'm going to not be using my 3D printed tie downs, but basically I got myself some trays, so I'll have one up here, and then one that comes down here, and then another one that runs along the top here. And basically that's going to catch my power from these guys, send them here, and then basically all the signals are going to come up and going to come back down into the motors. So this one here is just going to jump directly up, and this one's going to go loop around, come in, and then from here down that way, just to keep everything separate and nice and neat. And at the end of this, I'll be able to make myself a little electrical diagram and just stuff it in the back, stuff it in this box with the CD to the program, if ever in case one day I decide to upgrade or sell this unit. I'll have a very nice panel with the electrical schematic in it for anybody to learn or to know how I wired it. Because you might look at this panel and be like, oh well, random colors, grounds and whatever that is. But I mean, now I got my 3 pairs for the home, I got my 3 pairs for the limits, and then I have more than enough grounds for all of my wires. So basically I'm gonna need a ground for each wire. So basically I need 9 in total, since there's 3 motors, 3 limit switches, and 3 home switches. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically this will probably move on the bottom, because I will have to add my 24 and 48 volt 24 and 36 volt power in return. So basically I'll probably just move this over a couple inches, or I might just put the 24 and 36 on this side, since the panels will already be on this side. and I'll have a wire, like a wire thing up here, so I'll be able to just, you know, hide it directly in there as I come out. Hey guys, this is a couple days after. Just finally got my wire tracks, or what do you want to call it, cable trays, and a lot of my extrusion brackets, ball screws, and bearings. So I'm gonna get back to the panel. All right, guys, I'm gonna take a little break now. I'm gonna bring this downstairs next to my computer, hook it up, and see if I can get the X and the Z axis working. Basically, everything is wired, but I'm only gonna hook up 2 motors just to. I mean, if the first and the last one works, the middle one will probably work. Hooked up the power supply temporarily directly. Eventually this will be on the base of the panel. So basically it'll be inside of the cabinet. There will be one power supply on this side, and the other one, the 24-volt one, will be there. And then the wires are going to come up from here and there, and hook up the contactor, which will turn on and off the machine, and then hook up my 120, and then this will go all to this stuff. So basically, if you're wondering why I filmed all of this in time lapse, probably doesn't look like a lot of time in time lapse, but this was about 2 hours of work, 2-3 hours of work. So basically, then this, and I'm not done. I just got, I got the big part done, but now I gotta test to make sure the stuff still works, and then I have to mount this in the control panel, and then I'm gonna mount the power supplies, and then retest it with everything mounted that way, and then I should be pretty much good to go. Actually, before putting this in the panel, I'm gonna have to install all my little connectors. So I'm gonna have to make a whole bunch of holes with the step bit here, which the holes are all gonna be on this side. I'm not gonna have the panel in. I don't want a whole bunch of metal in it. And start pricing my wires for all of that. So basically, have some thicker gauge wire here for the motors, thinner gauge for the home switches or the limit switches. Don't think I'll have to order any more lugs. So so far it's going pretty good. I got all my stuff. The only thing I'm missing is the wire chain that'll go on the machine to loop the cables. I've got my, I don't know if I'm going to use this yet, but basically this would put two of these rails together. I got some 20x40 rails, and this is for 20x80. And I 3D printed myself some brackets somewhere. They are somewhere in here. I'm gonna have to find them. But I 3D printed myself some brackets the other day to hold two of these panels together. Then that would sandwich them. And after that, basically just be mounting the bearings to the, to the base of the machine. And basically, instead of having bearings for the y-axis, this would be the what would be my replacement for the linear rails, since these are like $130 each, and this was like $10. So I'm gonna try it out. If I can save some money, it'll be nice. Just looking real fast for those brackets I printed up the other day. Probably, oh, here they are on this workbench. Well, here's two of them. I know there's other ones here somewhere because I printed up 6 in total. I also printed up some stops for the bearings here, for these things, and these will go at the end, and there'll be a little set screw that I'm gonna have to put a nut insert in there, put it in with some heat, and then use a little set screw to lock it onto the shaft here, and like that the axis or the gantry can't go further than that, and that'll have a limit switch attached to it to act as a bracket at the same time. So still don't know how I'm gonna add the limit switch. I know I have the home one here, like the 3 homes. I had to modify this because when I went to go look in the wiring diagram, I thought I was using ground, because the other day when I tested these drivers, I'm pretty sure I used the ground to loop here. So in my head I was going to use more of these green and yellow ones for ground. But finally, if I look at the wiring diagram and I look at some of the stuff online, I really need to be using the 5 volts. But I'd have to look in some of the pictures I sent to my brother. I'm pretty sure when I sent it to him, I was using the ground side. I don't know if it changes anything. Maybe it does. Don't know. So I'll stop the video here. I'll go bring this all downstairs, test it out, and then I'll edit me putting this panel up together. Hey guys, just wanted to make a quick mention. For anybody wondering like why I'm filming all of this in slow-mo, I'm basically filming everything so somebody who wants to make their own one of these CNC machines, whether it be plasma cut, router, laser engraver. I know like some of these other options you could just buy, like for example the laser engraver, you could just buy it already made for a much cheaper cost. But it's just, doing a project from A to Z is just so much more gratifying at the end when you just build all of this and at the end it just works, and you can tell yourself that your next project could be even more complicated, because if you're able to do something like this, and I'm not done yet, I still got a whole bunch of stuff to do, but I just went to go test out my motors. They work with this, like, just quick setup, just to hook it up to my computer to see if it works. But man, if you could make a setup like this, imagine what you could do like in real life. Like, you make one of these, you could start building them, making sure they work, and selling them if you want. Or you could make yourself I want to make a CNC plasma cutter for making money. So you can make it as heavy duty as you want or as light duty as you want, and all dependent on your projects that you want to do in your life. Like I want to use this to make a little bit of profit making parts and selling them. Even my plan is to make industrial storage cabinets for inventory. So basically I want to do this, then cut my drawers out, fold them, and weld them together, and then make a cabinet, and voila, man. Just a great perspective on what you could do with these things. Like I got all my stuff. I'm in it for about $1,600 to $1,800. I will try to link the Excel sheet that I have in my Discord, and I will have the Discord in the video description for part 2. So if anybody wants to come ask some questions or suggest me things to do, things that I should do on my build, you're welcome to come and suggest, because some of these things that I've done came from one of the shorts where I asked for help for. So I think this is a good little project. If anybody wants to do something similar, I mean, you could definitely go the route of just buying something that's already made and modifying for your needs. Like I see so many videos about these laser engravers, like these 7.5 watt or 10 watt laser engravers that people just take off the engraver and wire a plasma cutter to it and use that, and they have like a nice little, like 20 by 20 cutting surface, and that's amazing. Like that's the kind of stuff that got me wanting to do a project like this. Except I want to make a 48. At first I wanted to make a 4x8 foot table, but when I was looking at the lead screws or the ball screws, basically like 60 inches was about the max that was like in my budget, or else it was like adding an extra $1,000 just to have one lead screw that has the length that I needed. And I was like, I'd much rather just pay $150 for a lead screw that works for 4 feet, instead of paying like $700 for a lead screw because I couldn't find anything else. Like deals on Amazon and stuff like that change all the time. But at the time that I was shopping to buy my stuff, basically I went with a 1,500 millimeter ball screw, which is, I think is about 58 inches, a little bit more than that, maybe 59. And I mean, that's plenty long for most of the cuts I'll ever be doing. I don't think I'll ever do something that's larger than 4x4. So basically I'm going to have all the space that I need to cut all my designs on, you know, in that 4x4 foot section. And, you know, and some, because my ball screws are 59 inches. So I mean, it's a really fun project. I encourage anybody who wants to do something like this to do it. I mean, this is what gets me excited for living my next day, is just projects like this. And same thing for at work. When I'm at work and I'm creating a machine or building a machine, it's the same kind of stuff, except I'm not building the control panel. I might be building an auxiliary panel, but for sure it's real cool when you build something from A to Z, and it's just, you like, you know, maybe some troubleshooting in the end, but man, when it works and you tell your, you know, your spouse or your wife that, you know, you built this machine and it's functional and you could show this to your friends and stuff like that, it's just a nice like wow effect to like your entourage, and you know, just a big motivation boost to push your skill even to the next level. So with that, I'll let you guys go, and I'm gonna go edit the video of just me wiring this panel, and then I might take a little break for the night. I still have, like I mentioned, I still have a couple things to do for the panel before I could put this back in the panel, now that I confirmed that the motors work. But I'm gonna take a little break, spend some time with the kids,